Does anybody need one? Okay, so the first one says draw an appropriate atom using one of the two methods you've learned in class. You should draw the Bohr and the Lewis structure for the elements of your choosing. We're skipping that one right now, but we're going to go back to it once we talk about the Lewis structure, okay? Number 2, what do you know about an atom if you know the atomic number and the atomic mass number?
How many electrons total?
You know protons, neutrons, electrons, and the element itself, don't you? If you've got those two things, you know all three of those. So write that on number 2 on this paper. You'll know the element, proton, neutron, and electron. In order to make an element from another element, what would you need to do? For example, if you have a zinc and you need to make a copper.
Add something else to it.
You would add something to it to make it an element. So let's look at our periodic table. Let's find zinc and let's find copper. All right, so where is zinc at?
Zinc is
Zinc is number 30 on your periodic table. Do you see zinc?
Yeah.
Number 30. Copper's right beside it, right? What's the difference between zinc and copper? The atomic number's different, right? You got 30 and you got 29.
So you'd add like hydrogen to it. Something like that.
Okay, so for if I had it on my atom board back there and I had zinc, how can I make it copper?
I add something with one electron to it, like hydrogen.
Okay, so if I have zinc, I need to take off 1 watt.
One electron.
Well, I know that the atomic number equals what?
30.
Proton and?
Neutron.
I know the atomic number equals proton and electron. Here we go again. Proton. Listen, this here is what you got to go back to. So based on that, that means you're going to take 1 proton and 1 electron off, correct? So right now you have 30 and you're going to move it down to 29. Since you know you're doing that, how does it change the neutron? What do you do to find the neutron for zinc? For copper. So the AMU is 64, Miss Sloan. And I'm going to take that from what? I'm sorry. I'll take that from what? The AMU from what? To get the neutrons. I'm trying to find neutrons. Taking the mass number, and I'm going to minus the atomic number. What is the atomic number for copper? 29. 64 from 29. Open your calculator up. Do the math. Yeah, it's 35. So what we did, are we going to add or are we going to subtract neutrons?
Subtract. Or no, you'd add them.
Well, we have 66 minus 30 for zinc, right? 66 minus 30 equals what? Huh? What? 36, right? So what am I going to do? I would take 1 neutron away too.
This is 65. It's not. This is 65.3.
Oh, I'm so sorry, Miss Aaron. But I was using that one up there, which says 65.39. but you are exactly right.
That's what
That would be 65. You are perfectly right. And that would make it 35. And so what would I do? Nothing. I took one proton off, one electron off, and I left the neutrons alone. You don't have a deep enough understanding of it yet, and it's okay. Don't think that you're doing bad because you don't understand how to do that. But you got to start learning how to think that way, okay? So let's look at the next one. The three substances of a particle is a proton, neutron, electron. How are these particles different? Okay, what does a proton do?
positive.
It is a positive, and where is it at?
On the inside of the nucleus.
In the nucleus. How do we find protons?
Atomic. That's a good question. 8 man.
Your atomic number.
Atomic number. All of that is what you would say. Give you a minute. Write it down on your paper. Try to get this figured out. Proton is a positive charged atom that is inside of the nucleus that you use the atomic number for. I'm writing down number 4. The proton, you will use the atomic number to find out how many. It's inside the nucleus and it has a positive charge.
What was the one we got for number 3?
You take one proton and electron and keep the neutron the same.
Okay, so what is a neutron? Where is a neutron located?
On the outside.
In the inside of the nucleus.
Does a neutron have to do anything with neutral?
Yes, because it is a positive negative charge.
Okay.
Okay, how do I find a neutron?
Atomic mass minus atomic number equals neutron.
Write that down. Can I give you a suggestion, sir? I'm going to do this every day. I'm going to write the atom down. I'm going to write the periodic table down. And I'm going to write 8 men down every day. And I'm going to drill this into your head until you get it. And you keep saying it to yourself and keep going back to the notes every day. And if you don't get it, write the notes in your ISM book every day.
Oh, what did we write for electron?
Huh?
What did we write for electron?
What did I write for electron? I haven't got there yet. I only did proton and neutron.
Thank you.
Okay? Now the electron. Where is electron located?
On the outside.
Outside. Right? What kind of charge does it have?
Negative.
Negative charge. How do I find the electron?
8 minutes, 30.
Atomic number. Do you have all that written down? Describe or draw a description of an energy level and electron cloud below. Energy level is what we've been doing. Okay?
That's the period.
What's the drama about?
Huh?
That's the period. What period is energy level?
What period it is? Yes, sir. It's what energy level. I like that. If you wanted to draw an example, you would just draw one of these methods, which is the Bohr method, right? What is the electron cloud model? The electron cloud model is just basically telling you that the electrons, sir, are out there just floating around like a cloud. They're not on an energy level. They're just out there. Okay? You good? All right. Use your brain too much. Let's go. We already did this side. Let's do this side. Now, I've already told you we're going to do this today, right? So what we're going to do is station 1 through 6 has a different element on it. Okay? When you go there, and I'm going to tell you to go, you will need to draw, you will need to label, and when I say switch, you're going to switch. Okay? Your job is to look at the stations. So let's look at our paper. Station 1, Station 2, Station 3, 4, 5, and 6. Do you know where they are in my room? If you go and you take your paper and you turn it this direction, that's going to tell you Station 1, Station 2, 3, 4, 5, and 6. Everybody good? What is your job? Your job is to go back there, and your job is to draw how many electrons that you have on what energy level and identify protons, neutrons, and then look over here. It says you have to put the atomic number on the left-hand side. You have to put the element on the right-hand side. You need to do the symbol on the bottom right and the atomic mass on the left. You're not going to do all that while you're doing the rotation station. The only thing you're doing is you're counting how many protons, how many neutrons, and you're drawing your structure. You're going to do the other part when we get back in our group again. Does anybody have any questions? All right, let's go back. Okay, you're at your station. So now what you're going to do is you're going to go ahead and draw your element, label everything. If you're in station 1, you're going to start on station 1. If you're station 2, you're going to start at station 2. If you're in station 3, you're going to start in station 3. Nobody's in 4. 5, you're drawing the structure, not touching anything. And number 6, you're drawing structure. Does anybody have any questions? Draw your element.